Hi, STEM oneers. Welcome to the last segment of graphing systems of inequalities. Yesterday you learned how to graph a linear inequality that was involving shading, and there was only one equation, or one inequality, excuse me. Today what you're going to learn is what happens if we have a system of inequalities. So system of inequalities just means, like you see here, you have more than one linear inequality. So systems of linear inequalities will have what I'm going to say is infinitely many solutions. Okay? Anything that falls in the shaded regions will have to make both inequalities true. All right, so here's an example. Let's say you're given the following system, and by following system I mean these two inequalities here. And what we want to see is when we graph these two linear inequalities, what I want to know is where would 0, 2 fall? Well, it would be considered a solution if when we substitute in 0 for x and 2 for y, it should make both inequalities true. So let's just see what happens. I'm going to take our first equation, and I'm not going to write x and y, or not equation, inequality, excuse me. And instead of writing x and y, I'm going to fill in the x value of 0 from the ordered pair and the y value of 2. And then we're just going to simplify. So 3 times 0 is 0. 4 times 2 is 8. 8 is less than 12. Well, yeah, that's true. So far, we got a yes. But the only way we can say yes is if it works or makes both inequalities true. So on the second one, we'll do the same thing. Let's just see if negative 2 times 0 plus 5 times 2, let's see if that is greater than or equal to 10. Well, again, we get 0 for the first one. 10 greater than or equal to 10. Well, yes, that is true because greater than or equal to means that it's either the same size or it's larger. And in this case, 10 is the same size as 10. So going back to the original question, we could say, yes, it is a solution because, oh, where's my edit undo? There we go. So I'm going to say yes, solution, since both inequalities were true. Both of them have to work, not just one. All right, visually, down below, I also imported the screenshot. I took this from that website, Desmos. And what you see happening here is you have the two inequalities that we graphed, and this blue line, this blue section, that's not blue. Let me get blue. There we go. This blue section got shaded above the blue line, and the red section got shaded below the red line. Well, you're going to notice that there's one section of the graph that got shaded twice. And where does that occur? Well, right here. And I'll use a highlighter because all the coloring now looks a mess. But this region here, this is considered our solution. All right, and so any point in this colored region would make both inequalities true. They can't be on the dashed line, but they can be on the solid line. So any points on the solid line within this region here, these would all work. Anything on the dashed line won't work. Anything in the colored region does work. So those are all ordered pairs that would make these inequalities true. Okay. In the business world, people use this stuff all the time to figure out potential costs and profits. So that's just an example. All right. Today your goal is really just to learn how to graph these. So I'm going to do 2 of them with you, and then I'll have you do 2 on your own, and the 2 you do on your own you'll bring up and check your work. So let me scroll this down so we can see the whole image. Based on what we learned yesterday, I know that this one is going to be a dashed line. And I know it's going to shade below since it's a less than symbol. All right, the second one is also going to be dashed because there is no equal sign underneath here. And this one's going to shade above. So with these, I would grab either colored pencils or make sure you're shading in different directions, and I'll show you what I mean by that. Let's start with the first one. So on this first inequality, we have a y-intercept of 1 and a slope of 2. So I'm going to rise 2, run 1. And we said we're going to use a dashed line. Okay, now for shading, really be careful here. I'm going to shade, this one says below the line. So I'm going to use kind of diagonal lines going this direction. All right, that way we can see that region pretty clearly. Now, if you have a highlighter or a crayon, you can actually go ahead and color that region in. That might actually even make it easier. Okay, if you don't have one, you can use lines. It doesn't really matter. Just make sure you can see that region. All right, now when we do the other one, we're going to put it on the same graph. And I'm going to use a different color on this one. So my y-intercept is at -2. And my slope is +1. So I'm going to go rise 1, run 1, rise 1, run 1, rise 1, run 1. And I'm going to keep backtracking the other direction. And this is also going to be a dashed line. Okay. Now, when we shade this, you need to make sure you're focusing only on the red line. So the red line, again, I'm going to use a highlighter. The red line starts right here, and we are going to shade above that. So notice the section I'm coloring right now doesn't overlap with the section that I shaded earlier, but right about here, let's see, get a different, oh, come on, there we go. Right in this section here, you can see we shaded twice. So this would be our solution set, this little tiny gap. Any ordered pair in this little sliver would make the first and second inequalities true. So double shade, the region that's double shaded, this is our solution. And notice there's more than one ordered pair. That's the whole idea. So we're finding lots and lots of ordered pairs that make those inequalities true. Okay, let's do one more. Y-intercept is at -2 on the next one. And my slope is 1/3, so I'm going to rise 1, run 3, and we're going to use a dashed line because there was no equal sign on this. Okay, and on this one, we're going to shade above since it's greater than. So again, I always try to get my lines kind of going at a diagonal just so I don't conflict those with the graph lines. All right, so all of that is shaded above the line. All right, I'm going to grab a different color. Again, if you have a different color, it's probably a good idea to grab that. And I'm going to go to my next y-intercept at 4. And this one has a slope of 1/2. So rise 1, run 2. Rise 1, run 2. Rise 1, run 2. And darn it, I think I set this one up wrong, but that's okay. We'll keep going. Okay, and this one's going to be a solid line. Okay, we are going to shade below that. And again, I'm going to kind of shade, we're focusing on the green line. I'm going to shade below the green line, but I'm going to put my pen kind of moving in a different direction. All right, there's only one part of this graph that got shaded twice, and it's wherever the colors overlap. So in this case, colors only overlap in this middle section. So this middle section, you just shade your solution nice and dark. That shows it's a solution. So wherever the darkest part of your graph is, that's considered your solution. So if you want to draw an arrow and point to it, you can do that. This is a solution. All right. So shade each region separately. Look for the overlap. Overlap is your solution. Your job at this point is to try the last two you see right here and bring them up. Just a hint on number 4. If there is no x value, maybe think of that as 0x plus 2 and realize this is going to be a horizontal line because the slope of 0 is horizontal. All right, give those a try, bring them up. Let's see how you're doing.